Okay. So, as per my understanding, your intention for doing this course is to learn more about the DevOps tools like Kubernetes, Docker, and CI/CD pipelines and these things. So we'll cover all of these things. So we'll start with the basics. So how we'll be proceeding with the course, we'll uh, not focus too much on the theory part. We'll focus more on the this demo and practical sessions. We'll do more of it. Theory part will come during the process, because without it is not possible. These demos will not be possible. But yeah, most of the things we'll cover on these demos and practical sessions. It also tell you what are the interview questions. So you're also planning for the interview questions, like planning for giving interviews on DevOps, or you are planning just for in your current role you want to implement these DevOps things.
Yeah, interviews. Yeah, that is important.
I am at the moment looking for jobs, so I need to focus on this. So
Okay.
I need something
So we will
catered
touch.
to
Okay,
more
so we'll
focus
touch
on
that aspect
getting
as
a
well.
job. Yeah.
So we'll touch that aspect as well. I'll tell you what are the popular interview questions people are asking these days on DevOps based on all the phases. And also what are the popular tools that are being used. So in this session, in this course, we'll not cover all the tools, because covering all the tools is practically impossible. But we'll cover at least one tool for every phase. Okay, for every DevOps phase, we'll cover at least one tool. So we'll cover the tool that is most popular in the market right now. Okay, and the idea would be like, if I tell you one tool, and if you have to work on similar tool in your organization, you should be comfortable with it, because concepts will exactly be the same. They can be, if you're using cloud, let's say you might be working on AWS, you might be working on Azure, you might be working on GCP. So the cloud concepts are same, right? You have networking services on all these things. You have storage services on all these providers. You have like different services, same set of services on all these providers, but only the namings and things would be different. That's it. Concepts and everything remain the same across every product. Okay, so we'll cover them as well. Okay. Then yeah, I'll be asking you to perform some tasks as well, like the normal demo sessions which I'm giving, and I expect you to work on that after you go home. And with DevOps, it's more of a troubleshooting kind of thing. Like you implement things, then there are some issues, you troubleshoot it, and no one is perfect in DevOps. This is the thing which we have to keep in mind. No one is perfect. You always have to Google things. You always have to use Google and troubleshoot things. There can be hundreds and different types of errors that might come. So just go and Google those errors if you face any. Try to read around it, and next time when you face it, so at that time your troubleshooting will be quick. So learning all those tools and technologies, this is how the process goes on, because there are new tools and new tools coming every day in the market in DevOps. Plus on the popular tools as well, there are new versions coming, new iterations coming on that. So it's very difficult to, so if I teach you something today, it is a very high probability that that particular thing might have changed in the next 3-4 days. It is very high probability. But as you know, in IT things are evolving, so you have to always be on track with what are the things that are going on. So that is what DevOps is all about. There are so many tools, and you have to be always updated on what is going on in the market right now, what the new things have come in that tool, and how that particular new thing you can leverage to improve your code, to improve your delivery part. Okay, so that is about DevOps. Okay, so we'll touch everything from the starting. Okay, so I'm sharing my screen. So how will be the course overview look? I'll share that. I guess you must have gone through this document which you might have seen. This is the 33-hour course. Can you see my screen? Is my screen visible? Prakash Shah?
Yes.
Yeah,
yes,
yeah,
yes.
yeah. I can see.
Okay. So let's keep this session very interactive. Okay. So whenever you have any doubt, just ask me. Multiple times you can ask me, because there might be things even I don't know. Because DevOps is a thing like that. No one knows everything in DevOps, and there are so many things in DevOps. No one can know everything. So there might be questions in your head that even I don't know. So I'll also take some time in the next session or in afterwards. I'll give you a time, and after that time, I'll tell you about it. If you're facing any issues, if you're facing any errors, so it's all about debugging and troubleshooting. Okay. So you guys just ask me whenever you have any doubt. Okay, I am happy to repeat it. Okay, and we'll focus
Uh,
more on demos and sessions, as I said. Yeah.
do we need to install some softwares before this? Like, you know.
Yeah, that I'll cover. Hmm. That I'll cover. So let's cover. Let's talk about the myths. Okay, the myths that are associated with DevOps. Okay, so first myth is people think that in DevOps coding is required. You have to be well versed with Java, Python, and Node.js, and these development, these all these things you have to be well versed with. But this is a myth. You can learn DevOps even without the knowledge of any programming language. Okay, there are basic concepts that are required for sure. For automations, you might use Python, and but that would be only for automation, only for your job. It will not be like you are going and developing a software, developing a code. It's not like you're developing a proper Python based application. We will not do that. That is a development that a developer will do. So DevOps you can learn without having a knowledge of any programming language. Okay, so in this part of the course, any programming language
When
is
we
not a part.
apply for jobs,
Mhm.
yeah, sorry. So when we apply for jobs, do they look for this background? Like, do we need to have some background in this development
Yes,
or?
yes. So when you see a JD for DevOps, you will see
Mhm.
everything, like everything in IT that you see will be there in the JD. But the
Okay.
thing is, you don't have to be expert in everything. That is the best thing
Okay.
about DevOps. You should
Okay.
know, you should know overview of everything. Like for programming language, let's say you should know at least one language. Okay.
Okay.
When I say know a language, I mean I'm not asking you to build an application, build a web application that
Yeah. Yeah.
runs on Python, build a web application then that runs on Java, be familiar with all the frameworks, Spring, Hibernate, and everything. That is not at
Yeah.
all required. You just
Okay.
have to be able to write a code, a normal
Yeah.
code with if else, with
Okay.
loop, with
Mm-hmm.
having a knowledge of some programming like data structures like list, queues, very basic,
Okay.
not
Okay.
very complex
Yeah.
things.
Yeah.
Okay, that thing.
All right.
Okay, this was the first myth. Second myth is that you need a prior IT experience to learn DevOps. Even that is not required. Okay, you should, again, I'm saying you should just know the basics. It's not like you should be expert in operation side, you should be expert in deployment side, you should be expert in this only then. So there are so many phases, and it's it's actually impossible for anyone to master every phase. No one can be perfect in all the phases of DevOps. Okay, we'll see what are the phases in DevOps, but no one can be perfect in all the phases. You have to be mix and match. Someone might be strong in building part, like or building part, like images and orchestrating. Some might be having good knowledge on monitoring things using like cloud services. You might have used like Cloud Formation, this Cloud Watch, and so DevOps is a mix and match of everything. We see it's a mix and match of everything. Everything you will see in DevOps. Okay, so these are the myths associated with DevOps, and anyone can learn DevOps. It's not like uh, you have to be a pro in everything and then you will be learning it. So since you have made your mind in switching your career into DevOps, so learning will be part of it. So whatever tools and technologies we are using, you will learn. And when I'm telling you, you will learn this a particular tool which I'm teaching, there will be multiple tools similar to that tool. Okay, if I teach you one tool, it will be very easy for you to go through other tool. Okay, for example, like now, right now, as I gave an example, like right now, you are well versed with AWS. You have already done this AWS certification. You must have already gone through the AWS course. So tomorrow, if I tell you, go and learn Azure, go and learn GCP. Okay, so let's say for AWS, you took 2 months of time to prepare, to get the concept, to do demos and practicals and everything, and get certification. For Azure and GCP, you will take just 15 days. Okay, this is how your learning curve increases. Okay, so that is the thing here. So let's see what are the things in the course you'll be covering. So that will be around approximately a 33-hour course. It might be a bit more as well, because it depends on how much time we are spending and how much time we take into debugging, and some issues might coming. And so assuming minimum 33 hours we'll spend. Okay, we'll cover DevOps basic. We'll do that today. We'll do DevOps basic today. Overview of CI/CD and stages and these things. So we'll start with Git also today. We'll see how the time allows us. And tomorrow we'll finish Git, or at least we'll cover say 60-70% of Git. Okay, then some part of Git we'll leave for the next session, or maybe if possible, if we are trying to extend tomorrow, we'll cover Git as well tomorrow. Okay, then there comes these things, Jenkins, Maven, and SonarQube. So these are the code these are pipeline stuff. So we'll see everything. Code building and SonarQube will be for code quality checks and these things. So we'll see that. Then we'll study Ansible. Then there'll be some Docker, then Kubernetes. So all of these things we'll not go into very detail. It's like I'll teach you things which are required, which you will be needing to work in your organization. So this is not a course for Kubernetes certified, like CK. It's not a CKAD course. If you go for a CKAD course, then this will be like 100 hours, I guess, 70 hours or 100 hours course for only for just for Kubernetes, because there are so many things in Kubernetes that no one can cover. This is a DevOps course. So here I'll give you knowledge of all the DevOps tools, and it will be a starting point for you to dwell deep into individual topics. Okay, and I'll cover all the topics that are required, that you will see in the JD, in any DevOps JD, and what are the interview questions that the interviewer might ask you for going for a DevOps role. Okay, so if you're going for specifically for Kubernetes, if you're going for specifically for Kubernetes job, so you might have to learn more on Kubernetes. You might have to do Kubernetes certification, or go deep into Kubernetes thing. So this will be just a starting point into Kubernetes and cracking Kubernetes interview. It will be not like it will not allow you to, like, you'll have to spend some time. You get the idea, right? Then we'll discuss about AWS CI/CD, some code build, code deploy, and code commit. These are the three services which AWS provides regarding DevOps. Okay, so you both are from AWS background, right? You both have AWS knowledge, right?
Yeah, we learned both AWS and Azure as well.
Okay, Azure as well. So here, Azure we'll not cover. We'll take all the things that we are doing. We'll use AWS only. Okay, we'll create EC2 instances, it deploys things, and we'll use it. So we'll use AWS as our infrastructure. Okay.
Okay,
we'll
sure.
use all the
Yeah.
AWS things for our infrastructure. Yeah. Okay, then we'll discuss monitoring. Okay, so all these stages we'll cover. So all these popular tools we'll cover. So I mentioned the tools as well here. Okay, we'll cover Jenkins, Maven, SonarQube. So here also, then we'll use Ansible, then Docker, then Kubernetes, then AWS is cloud. So we'll use cloud AWS overall for deploying all the servers, deploying things on the servers and EC2 instances. For monitoring, we'll cover one of these things, either Azure's ELK stack or Prometheus. So it depends on, we might cover more of the things. It depends on the time, and if you have any more questions, and then we'll cover more. Okay, so this was a basic overview of the DevOps course that we're having.
Okay.
Any questions on that?
No, I don't have anything.
Okay. So yeah. So you already have like 10-15 years in IT industry, so you must have known about how the things in IT industry work. Okay, you already know, I guess. So it would be like a project comes to a company. Okay, how do they manage that project? That there is a client, and there is the client is a person who gives you all the requirements. Okay, when you get a project, you get all the requirements from the client. Then you have someone in the uh, at the managerial role who discusses all the requirement. He manages all the team. In the team, you have team full of developers, testers, and everyone, and they do all the tasks and all the operations, related, development related, testing related, all the tasks they do, and those things. So this is how a normal thing in IT works. Okay, but I will discuss more on it based on like software development methodologies. So what is a software development methodology? Software development methodology is how we develop softwares in IT. Okay, how we develop softwares in IT. So there can be various stages, starting from planning, like how, when the things come in, when the project comes to a company, how they plan and how they deliver the project. So there are many things involved in the process. Okay, so how the thing started earlier, like as we know, IT is completely is always evolving, right? So they see what are the shortcomings of XYZ thing, they improve on it, and they bring up a new approach. Then on this new approach, they work on it for some time. Okay, then they see some shortcoming, they improve this process, and they come to a newer process. So this is how things in IT work, right? So initially, when this all started, software developing methodologies and these things came in, how to develop softwares. So things started with the waterfall model. Okay, so this is all called software development lifecycle, SDLC. You must have heard the word SDLC, software development lifecycle. So there are various processes and there are various phases involved in software development lifecycle. Okay, software development lifecycle is the life cycle of, like, it will contain all the stages that are involved to deliver a software to your client. Okay, so there are various methodologies that are involved. Okay, so first, initially we had something called a waterfall model. You know, a waterfall is like something flowing from the top. So that is how waterfall model is. Okay, so everything will be starting with requirement. Okay, when a project comes in, your client will give you a requirement. Okay, this is the thing that we are going to develop. Okay, this is the requirement, this is what the user is expecting. This will be how the pages will look. Let's say it's a web application. Let's say this is how the pages will look. This is what the intention of this pages. This is what the total overall application will look. Okay, so all the requirements your client will tell to the team. Okay, then there is something called so this is the process of requirement gathering. Your team will gather the requirement from the client. Okay, and requirement gathering will be based on what are the things that have to be implemented. Okay, so requirements can be functional and non-functional. Okay, functional requirement as in, if you talk about web application, let's say your functional requirement will say, okay, this is a web application. Okay, so there are users associated in various countries across the globe. Like if you say example Amazon, okay, Amazon website can be accessed by multiple people across the globe. So requirement here would be, functional requirement would be all the pages. It would be customer page, it will be payments page, it will be orders page. Then what are the pages doing? What is the customer? What is the person who is accessing this page will be seeing it? All these things related to it. Then non-functional requirement will be, what will be the latency? Like how fast, when a person clicks submit, how fast the response comes back to him. When a person clicks on the order, how fast the order goes into the cart. Okay, when he performs a payment, how fast the payments goes in. So that is all non-functional requirement is. So there can be requirements of multiple things. Okay, then there is a design phase. After this requirement gathering, there is a design phase. Based on the requirement that is gathered from the client, there is a design happening. In design, what happens? They prepare, they do a planning. Okay, this is what the customer needs. This is the number of pages they have. So how we'll design? We'll create. We'll use these. This is the logic we are going to use. Not on not on the logic part. It will be like these are the languages we are going to use. This is a technical stack we are going to use. These are database we are going to use, and we will distribute our work among this, and they'll be like it is requiring multiple pages. So we'll have a separate coding for this. We have a separate code for this. So so design phase is basically the architecting phase. How you architect those requirements and provide something to the developers. Developers are the person who will implement it. Okay, but what do they do in this implementation phase? They code it, right? They write the code. They do all the database related things, write the code, and the code fetches the data from the database or stores the data into the database, and so that is all implementation part. Okay, how the code is actually implemented. Then there is a verification part. Verification part is nothing but a testing. You can assume it's a testing phase where after you implement the thing, something is developed, right? Something is developed. So now you have to verify it, whether it is working fine or not. So you do testing, you do a testing of that thing. So that is verification. After the verification, what you do? You deploy that onto a server. Okay. So verification comes afterwards only. Like after implementation, what you do? You deploy that thing onto a server, right? And after that deployment thing happens, you verify it, whether everything is working fine or not, whether what the customer wants, all the requirements that my customer gave, does my software which I am going to deliver, does it fulfill everything? So I'll verify it. Okay. Then comes the maintenance part. Okay. After verification, what happens? My customer, I'll give so I'll deliver these things to the customer, and customer is using it. So now comes the maintenance part. While he is using it, there might be various things that has to be done, right? There might be he might be facing some issues. There might be some errors. For example, sometimes the memory goes too high, the requests are failing, or the server goes down. So all these are the maintenance activities has to be going on, right? So this was the waterfall model. Why do we say it a waterfall model? Because in this, we are delivering everything after a long time. So you can assume it like a construction of a building. Okay, a person who is so when a building constructs, it will be delivered only after the whole building is delivered. Whole building is constructed properly. Everything is working fine. They have verified it. Okay, the electricity supply is also working. Water supply is also working. After then only they will deliver those flats to the client, right? So, to the person. So now if the person says, okay, I don't like this map. Okay, after he gets it, after the person gets his delivery of his flat, he says, no, I don't like this kitchen. The kitchen should be in this location. I want 2 BHK instead of 3 BHK. So now nothing can happen, right? Now the whole building has to be destroyed, and then a new building has to be created. Correct. So that is what happens in the waterfall model. So once the requirement happens, it freezes. Design happens, it freezes. Implementation happens, it freezes. Now after implementation, everything is ready. Your code and everything is ready. So if the new requirement comes in, again there will be a design for it. Okay, again there will be implementation for it, new implementation for it. And the new thing which you have, the code which you have written, you have to make a lot of changes to it. Then again after that you have to do a re-verification again, then you have to deploy. So it's a whole process. You cannot go back to a previous step. Like you are in a, let's say you are in a verification step, again you will if you are in a waterfall model, you will again go through all the steps. You will have to go through a requirement, you have to redesign it, and then you have to implement it again, and then again verify. So that is why we call it a waterfall model. So this was a very strict model. Okay, so and it took around like when a requirement comes in, and to fulfill all the requirements and to prepare an end product and to give it back to the customer. It used to take a lot of time. It had to go through all the process. Okay, only after that the product could be delivered to the customer. Okay, let's say it took around 10 months. He gave a requirement for to implement something, and it took 10 months to implement all these things. So for 10 months this customer was waiting. This customer was waiting for 10 months for a final product. And what happens? He got that product. He saw some issues. He saw that, okay, I did not want this requirement. I wanted something else. Now what he'll do? He'll do a re-requirement. He'll give a requirement again. So again there'll be requirement gathering phase, new design, new implementation, again a verification. Then he'll get a new product. So it'll be like again he'll get a product after 8 months. So it'll be like this was not an ideal approach for a software development, right? So people started thinking of something else, other approaches people started thinking. Okay, you got what are the shortcomings of this model, right? Shah, Prakash?
Yes, yeah, definitely.
Okay, so now people started thinking of new things. So then what came into picture? Agile. Then came into picture this agile. So what happens in agile? In agile, what we do? Like we divide our requirements into various stories, in various sections, in various modules. We divide it. Okay, and now we do not focus on the whole application at once. Okay, we focus on iterations. Okay, we focus on iterations. In agile, now my customer does not have to wait for 8 or 10 months to get the final product. He can get products in iteration, small developments in iteration. Okay, for example, let's take an example of waterfall model. We took an example of Amazon website, right? We had let's say we had a login page, we had a customer page, then we had orders page, we have items page, we had payments page, we had a cart page. Okay, we had so many pages. So now what would happen in a waterfall model? We'll get all the requirements, we'll design everything, we'll design all the pages at once. Okay, after some time we'll do all the implementation, write the code for everything, all those pages, then do testing and everything. Then after the whole website is ready, then we'll deliver it to the client. Okay, but in agile it's not like that. We'll deliver in iterations now. Okay, we'll deliver in iteration as in we'll figure out some logical we'll do some logical sections, we'll do some logical divisions of our tasks. Okay, and deliver it in iterative way. Let's say in first iteration we are only giving the login and logout page. Okay, then for that what we'll do? So for that we'll do a planning. Okay, what will happen in the planning? We'll plan, okay, this is a login and logout page we have to deliver. Okay, so this is how the things will go. We'll do this and this. We'll have this kind of button. We'll have this kind of page. Okay, there'll be a name thing showing. There'll be a password thing showing. So all the plannings, like all the plannings, which will be planning as in how we are going to plan. Then will be design. In design, we'll discuss like all the things that we are doing. Like, okay, these are the pages that this is the page that we are designing. So as in architecting the page, architecting that particular module. I mean, you can assume a login page or a payment page. Only for that thing we are focusing on right now. Okay, then we'll develop it using whatever front-end technology we are going to develop it. We can use Node.js, we can use any JavaScript or HTML, CSS, whatever we can do. We can develop it. We'll test it. Okay, then we'll deploy it. Okay, then after deploying, we'll review if it is working or not. Okay, so and then we'll deliver it. Okay, then we'll deliver it. Now my customer might see this login page in just 10 days. Okay, it took me 10 days to do everything. Okay, now my login page is ready in 10 days. Now I'll shift to the next phase. Next is as in next iteration. Let's say my next iteration is related to payments and login. Okay, let's say no, payments will come afterwards. Let's say so. My second iteration would be for the payment this login page and orders page. Let's say okay. So here I'll do all the planning and designing for these two pages. Like login page I've already designed. So now I'll do the planning and designing for my orders page. Again, there'll be some things like development, testing, deploy, review, and how this is integrated with the a login page, because when someone logins, only then he'll show the order page, how those things are linked. Okay, then after this iteration, I'll launch it. So after 15 days, now my customer has two things. He has login page as well as he has orders page. Now let's say my next iteration is cart. Okay, cart and ordering cart page. Okay, so in that iteration, I'll add some logics on the cart. I'll develop that. Okay, this is how the things work. That a person will select something on the orders page, and when he selects it, it will go into his cart. Okay, and we'll again do a development. I'll do a testing of that cart thing. Now I'll do all the combined testing. It will be something integration testing. We'll do a login as well as we'll do we'll see the orders. Okay, when someone clicks on the orders, it will add to the cart. So everything will be, so after doing a deployment and review, the things will be launched. Now the customer after 15 days is able to see the login page, the orders page, and the cart page. Similarly, in the fourth iteration, we will do something for the payments page. So see here, my customer is not waiting for 8 months to see anything. He can see iterations after 15 days. Or 15 days or n number of days, it can depend. Okay, he can see iterations in n number of days. So if any changes he want to suggest, let's say after second phase, he's suggesting, okay, in the logic page I want to make some changes. So again, in the logic, in the login page I can do changes, because my things are not very strict right now. I have not delivered everything, like delivered the whole website and I have given to it, and then he's suggesting many changes. So right now I'm flexible to implement all those changes. I'll create one more iteration. Okay, I'll implement those changes that he's saying, and I'll deliver it. Okay, so he'll again verify it. Okay, this is okay. Now the things which I have given, the requirements which I have given for this login page changes, now they're implemented. Now things are perfect. Okay, so here he will see, now this is here you are collaborating with your customer every time, like you are collaborating with him continuously, and you are delivering him things as per his requirement whenever he needs. Okay, so this is it's a continuous process. Okay, you got the idea, right? What is agile?
Yeah, yes, it's an iterative cyclic process.
It's here that things are based on iteration. Okay. So, but again, there were some issues people saw with agile. Issues as in there are multiple teams associated with development, right? You have deployment, you have testing team, you have operations team, you have development team. So there were multiple teams which are associated with it. So it will be like there were some gaps between all these teams. So agile was able to bridge the gap between your client and your teams. Okay, between your development and your client, agile was able to fix the gap. So earlier, what was the gap in waterfall? What was the gap? The gap was the customer had to wait for 8 or 10 months to get his things working, to see at least if things have been implemented. Okay, this was a gap. When some requirements used to change, he again had to wait for a long time to see, okay, my requirements have been successfully implemented. So this was a big gap. So now with agile, this gap is bridged. Now they are very easily communicating with each other. The customer and the developers. These guys are very easily collaborating and connecting with each other. Whatever customer is suggesting, whatever this client is suggesting, developing team is doing those things. Okay, and after 15-20 days, and the client is able to see what he's getting, what the things he's getting, and again he's suggesting a change. They're again doing the change and delivering it. So that gap is being bridged here. But what happened is there are multiple teams in agile. So, but all the teams, there will be some collaboration issues among the teams. Okay, so let's say there is a development team. Okay, let's say there is a development team. I'll come to here. So what happens? So you have customer and software, the software customer plus software requirement, you can say. So this is your client, you can assume. Okay, so agile was able to bridge the gap between your developer tester and your customer. So now they are easily able to develop and test the things as per your customer requirement and deliver him in iterations. But there is also interaction between developer and operations person, right? What does an operations person do? Person in the operations or person of the IT infrastructure, what he would do? He would like do the deployments plus he will also maintain all the infrastructure, like your code and applications and everything would be deployed somewhere, right? Would be deployed on some servers, databases, and those things. So there might be some issues. There might be you might be so there might be some issues in the servers. There might be some memory issues in the databases, and plus the people who are using this application, the end users, they might also face some issues, right? They might not be able to. They might be seeing some error pages, let's say, or in case of like very high traffic, let's say, in case of during Christmas, New Year, when the traffic on the web applications is very high. So at that time, they might be facing some downtime, let's say. So they might face various issues. So there must be some operations team as well, right? Whose main purpose should be for this, whose main aim is to for customer satisfaction. Customer satisfaction as in the person who is using, the people who are using the product, people who are using this application, all those issues they are facing, there should be someone who is sitting there who should see if everything is working fine or not. Okay, to monitor those things. He is not the developer and tester. Developer and tester, they are developing and testing the things, but the things have to be deployed. After deployment, things have to be monitored continuously. If the things are working fine or not, if the people who are using it are satisfied or not, if they are facing any issues or not. Okay. So there was a gap. There was a gap between these developers and testers and operations people. Agile was not able to bridge that particular gap. Okay, because let's tell me why there comes a gap between developer, tester, and people in operations. Can you guess? Like, with your experience, can you guess? Like, when someone is developing an application, what is his mindset when he's developing an application? And when someone is in operation side, what is his mindset? You're working on a network and infra side, right? Networking side.
Hello. Yeah.
So tell me, like, what leads to the gap between this developer, tester, and operations people?
What gap? Communication gaps.
Yes, communication gaps. So it can be gaps. Why do the gaps happen? Gaps happen because of the intention. Correct. Yeah. Correct. What is the intention of developer and tester? Developer and tester's intention is
they want to just stick to their part of the work, isn't it?
Correct. Yeah. What is their job? Their job is for coding. Okay, yeah. They will do the code. They will write the business logic. They will see that everything is working fine on development environment, testing environment is working fine or not. But development environment we know that, right? Development environment is not exactly same as production environment. Correct. Production environment is like heavily built for production. It is built heavily for heavy traffic and very high, very complex infrastructure, very high-end infrastructure. That is our production environment, because we want that on production, we want uh, very high performance. Like the people who are end person and people who are using the application, they might not face any latency. They are always satisfied. It's because there are people who are interacting with that application, right? And that application is deployed on production. So that is our impacting our business. Correct. So the thing which is impacting our business and is monetary thing, so that has to be taken care first. Correct. So that is why on production, our systems and applications, those are very robust. The systems and the infrastructure is very robust. It's a high-end infrastructure, and we might not need those high-end infrastructure when we are developing and testing. Correct. Developing and testing can work in even a small environment. I might start developing on my anything on my normal, like 1 GB RAM and 200 GB hard drive. I can that is sufficient for my normal development and testing. If you know about, like, if you have worked on AWS, so you have multiple types of machines, right? T2 micro, T2. So you must have used T2 micro only most of the time while doing all the testings and all the POCs and all the demos. Why do we use T2 micro? Because we don't need the high capacity there. Okay, but do we use T2 micro and free tier things on production? No, we don't use, because production traffics are very high. These traffics are T2 micro and something like which is having very less memory and CPUs and those things. These servers cannot handle those things. Same goes for the databases. Okay, so every equipment we are using on the production, that is pretty different, very different from the ones which we are using in development and testing. So this leads to a gap. So people who are developer and tester, they develop things, okay, based on their developer mindset. Okay, based on their thing, and where they're developing on their development environments, and development environments are not exactly the same as production environment. So there is very high probability that the things they have developed on their development environment might not work exactly the same on production, because the infrastructure is different, right? So this is a gap. And also the mindset. My developer mindset is more on the coding. My business logic should work. My coding should work. But my operations mindset. What is my operations mindset? Operations mindset is I'm more concerned of the uptime. Uptime means my application needs to be up. The person who is using it, the end customers who are using it, should not face any downtime. Okay, so that is my operations mindset. Okay, I'm worried about monitoring. I'm worried about escalations. So that is my pain point. So developer is not worried about that. Developer is not worried about what is happening on the production and what is happening. Is the end user experiencing heavy traffic, or is he facing any errors or things like that? Developer is not worried about those things. He will work on it only when person from the operation tells him that, okay, listen, developer, you have not developed thing correctly. You have not worked properly. The application that you gave us and we deployed on production, this is not working properly, and end user are facing some errors. Now please go and fix it. Okay, so this sometimes lead to friction between these two guys, right? There is some blame game happens. What is a blame game happening? Developer will say, okay, my things were working fine on development environment. You must have done something that it is not working on production. Operations guy will say, no, you must have done something wrong in the development environment. Why did you not use this production infrastructure to deploy? So there is a lot of friction which might happen between. So there was a gap which Agile was not able to address. Okay, got it? Any questions? Any doubts on this?
No, no, this is clear. Thank you.
So then came DevOps. Okay, then came DevOps. DevOps is focused more on, as the name says, DevOps, development operations. So here, this gap between your developer and operations guy is bridged. Okay, now they are working in a proper collaboration. There is less friction. There is no friction among them. Okay, so DevOps was able to bridge the gap. So now we'll see what is DevOps and how did it bridge the gap. Okay, we'll see that. So this history is clear. How did the DevOps come into picture?
Yeah.
Like all the stages. So we are discussing all these things because we have to go for the basics, right? Because before understanding this solution, we have to understand the problem.
Yeah.
Okay. So it's not like Agile is bad. Agile was bridging a gap between your customer and your developer. So it is a good thing, right? So it's not like we are completely saying that we'll never use Agile and we'll always go for DevOps. We'll use both of the things. So both of these things are being used actually. So we want to bridge the gap between customer and developer, as well as the developer and operations, right? So we always use Agile and DevOps together.
Okay.
Okay. So coming to the textbook definition of DevOps. So DevOps is a combination of software developers and operations. Okay. As it says, Dev and Ops. It is defined as a software engineering methodology which aims to integrate the work of a software developer and software operation teams by facilitating a culture of collaboration and shared responsibility. See, here it is the culture of collaboration and shared responsibility. All are working, all the developers and operations people are working in proper collaboration. It's a way of working. DevOps is actually a way of working. Okay. So as we know that what are the phases that we have in software development lifecycle? First, we do a plan. We create a plan. Okay. Then we code based on the plan. Plan is nothing but getting the requirements and planning what to do, what to implement. Okay, how to architect the things. So that is planning. Okay. Then there's coding. Coding is how we implement it. Okay, all the coding, using all the coding languages, programming languages, and these things. Then there is a build. What is a build? Build is like if you write a code is nothing. Code is just a language. So you have to deploy it somewhere, right? You have to create an artifact. What is an artifact? Artifact is code. In building phase, what do? Like you write a code, you write a Java code, let's say. But you have to, how do you package a Java code? You create a jar file, correct? So with that code, you create a jar file. So that is called building. Okay, so you build a code and create an executable file. So when, let's say I write an application, I prepare a code, I write a full 2000 lines of Java code. So I'll not give this code to my end developer. I'll not give this code to my end user to, okay, I'm giving you the code, just go and run it every time. I'll give him an executable, correct? I'll give him an executable that he can use. Okay, just click on this and your code will run. We'll give that executable to him. So building is nothing but building the code to create an executable. Okay, then after building, we do a testing of it. So this blue thing you are seeing is the development part of the thing. Okay, is the development part. This is what the developer will do. Developer will do a planning. Okay, he'll do a planning. He'll write the code. He'll build it, create a jar, and he'll test it. He'll do a unit test using. There are many unit test frameworks available. So using using those frameworks, he can do a unit. He can write some unit test, and whatever things he coded, he can do a unit test. And on the yellow side, what you see is the deploy. Yellow things, what you see, these yellow things are, sorry, orange things, these are for operations. Okay, after the things are tested, this developer jobs is over. Developer job is over. Don't see the integration part. Let's say we are not integrating anything right now. Okay, let's say this blue is separate and orange is separate. Okay, now after plan, code, build and test, the role of developer is over. Okay, now the role of operations guy will come into picture. What operations guy will do? He will deploy it. Okay, he will operate it. Operate as in, there might be things that the end user might want. Like he might be facing some issues. Okay, then he has to monitor the things. The operations guy will have to monitor those things. There will be many various network elements, network equipment. For example, your servers, your databases, etc. He has to operate on those things. Okay, monitor all those things, monitor the application, and see if the end users are getting any issues or not, if they are satisfied with the working of that application or not. So these things are done by operations team. Okay, so DevOps is integration of blue and yellow. Okay, this blue thing is for developers and yellow orange thing was for operations. So DevOps is the integration of all these things. Okay, so now they are collaborating with each other, and it is leading to very good delivery of your application, faster delivery of your application. How is it fast? Because here also things are here also the same. It's not like that we are again going back to the waterfall model and doing everything from scratch and delivering everything to the customer after 10-11 months. So in DevOps, what we do here also, we plan and we break our requirements into various logical divisions. Okay, and here also there is some iterations happening. We'll deliver those things in the part. We'll deliver all those things in the part. So similar thing what we discussed here in the agile methodology, what we discussed here: test, develop, review, and these things. So we'll discuss in the part. But the difference between agile and agile and DevOps is we already discussed, right? About bridging the gap. It was bridging the gap between agile was bridging the gap between your customer and developer, and your DevOps is bridging the gap between developers and operations. Okay, so this is the development side of it: plan, code, build, and test, and deploy, operate, and monitor is the operations side of any software development. Okay, so this is what DevOps is doing. So see, if we see DevOps, these are the tasks for developers. Like these are the aim of a developer, you can say. So application performance, application should perform well. End user analytics, they do. Then quality code should have a quality. Then code level errors they have to check. Operations, what they have to make sure? They have to make sure the uptime, that the application is always up. They have to think about the SLAs. Okay, SLAs are service level agreements. Like you define an SLA before for all the projects. You define an SLA that okay, the application which I'm deploying, the application which I'm delivering will be up 99% of the time. Okay, so it should not be down more than 3 hours or 4 hours. If it is more than 3 hours, then this will happen. So these are all SLAs, agreements. These are all agreements that happen when you get a project. Okay, they have to. So operations team has to worry about all these things: SLAs, uptime, and application performance. How this application is performing. How this are the users, end user complaints. Like if the end users are getting facing any issues, are they complaining? So these are things operations person has to focus on. Okay, so development operation will come if you combine it, you do everything. Okay, you do everything. You are worried about everything now. So this is what DevOps is. Okay, got it? Got the idea of DevOps?
Yes.
Okay, here also this picture is almost similar. So here you have developers and testers. They are worried about writing the code and you see laptops, computers here. But IT operations, you see servers, storages, hard drives. So they also have the job of monitoring those equipments as well, right? Monitoring of the infrastructure as well, servers, storages, these things they have to monitor.
Yeah.
So for DevOps, you must have seen this diagram everywhere.
Yeah. Everybody copying that also.
Yeah, so this is the diagram you must have seen everywhere. So this is the same thing. So how this DevOps loop goes, you do a planning. Okay, same stages, nothing different. Everything we already discussed. So you know what is the planning, right? Before the coding, you have to plan it. Then you code, then you build it, create an artifact. Okay, then you test it. Okay, then you release it. Releasing it, nothing but deploying it somewhere. Right. After you test, so this part is still till this plan, code, building, test. This was for developers, correct? So now, after it gets released, releasing it is nothing but deploying it somewhere. Like how do you release it? Where do you want releasing the things? Like you want to release it in production, you want to make it live on UAT, or you have various type of servers, correct? You must be already knowing what are the types of environments we have on like when we're working. We have dev environments, we have test environments, we have UAT environments. UAT environments is user acceptance testing. Okay, so you have pre-prod environments, then you have prod environments. You know these, right?
Yeah.
You know these, right? So I don't need to cover all these basics, right?
Yeah.
Okay, so you must be knowing it. So pre-prod is nothing but it's like before prod, you need something to verify. Just before deploying something into production, you need an environment that is very similar to production. Okay, but it is not getting the traffic, the real traffic. So that is why we have a pre-prod environment. So we deploy on the pre-prod first, check if everything is working, and then deploy on the prod environment. Okay, an application is running on the prod environment, and let's say a new version of the application comes in. What happens? We again go through all the phases, and we deploy that new version 2 on the pre-prod. Test it properly if everything is working on pre-prod or not. Only if we verify that, okay, if we get a go that okay, things are working perfectly on pre-prod, only then we'll deploy it on production. Okay, so before pre-prod, you have a UAT, user acceptance testing. So there, you run some tests. You prepare some test cases where you verify everything. Like all those test cases what you write will be based on all the requirements. So all the testing will happen. So that is for testing. So again and then there is a development environment. You already know what is development environment. It is for basic development and normal testing, unit testing and normal testing. We use it. Okay, so there can be other environments as well based on, it depends on organization and projects. So they can be pre-prod 1, pre-prod 2. Some organizations have 2 pre-prod environments. Some have integration test environments. Some call it QA environments. But ideally, basically your environment should be like, you have a dev environment, you have a QA environment, and then a pre-prod and a prod. Majorly you have these 4 types of environments. Okay. So once you release, it gets deployed. Okay, after it gets deployed, then comes a part of operating and monitoring. once you have deployed, you are like, there might be things that you are upgrading. For example, let's say on your you were using something, any database, particular database you're using, or any server you were using. So there might be some security patches that needs to be installed there. Okay, so you will install those security patches on your infrastructure. Okay, plus there can be some other operations. For example, uh, uh, your user might be facing some issues. For example, some memory related issues, or we'll see what the issues can be there. So we have this operate phase for that. Okay, whatever patches and whatever things we want to deploy on that, so we'll deploy in this phase. Then monitoring is a phase. So monitoring is a phase where we know that what is monitoring, right? So this can be your application level monitoring, like on your application, how your application is behaving. Okay, how many requests is it receiving per second, and what is the latency? Like how are the people who are the end users facing any difficulty or not? And if there are any errors, how to monitor those errors, logging, how to check the logs. Okay, so you have many solutions for monitoring as well. So for all so these are all the stages. These are all the DevOps. These are all the DevOps stages. Okay, and these, you see, it is continuous. It's not like there is a break in between. It's continuous. It goes on and on. It goes on and on. Okay, here also you will have iteration, because as I said, in ideally in projects we combine both of these things, agile and DevOps. Okay, so there also here also we in DevOps also we'll have iterations. Okay, we'll have iterations. We'll have things coming from our uh, uh, clients in iterations. Okay, they'll also not give everything in the straight away, that okay, I need to build an Amazon website. They will not say like that. Okay, they also know that we are working in this way. Okay, so there'll be requirements coming in iterative fashion. They might say, okay, this is the thing, this is in iteration one, you have to deliver this. In iteration 2, you have to deliver this. In iteration 3, you have to deliver this. So for all these iterations, you go through all of these process, all of these stages. You do a plan, you go do a code, build, test, then release and deploy, then operate and monitor. Then again, a new version comes in, you again do a plan, code, build, whatever. So this goes on and on. Okay, so this is what DevOps is. So here, how it is collaborated with, so now, so DevOps is now, it is solving many problems, right? It is solving, your DevOps methodology is solving various problems that we had in waterfall and agile. Okay, so with DevOps, so what happens here is, in agile and DevOps, what we have is, we have something called sprint. Okay, we have something called sprint. Sprint is nothing but it's a time duration of an iteration. Okay, every sprint will have a deliverable. So let's say our application, let's say, has to be delivered in uh, 5 months. Okay, so we will logically divide our application into various phases, not phases, into various modules. Okay, this part of the application will take this much of this amount of days. This part will take this amount of days. This part will take this amount of days. And after like 2-3 months, we'll be able to deliver everything. So we'll say something like this. So sprint is usually for 14 days, and for starting of the sprint, when the sprint, before the sprint start, we plan the sprint. Okay, we plan the sprint. Okay, in this sprint, we are going to deliver this. We are going to deliver XYZ amount of things. We make a list. Okay, and every day on that sprint, like the sprint is of 14 days, we work on those items. Okay, we work on those items, and then we deliver those things. We come to a conclusion that okay, in this sprint, these are the things that we have delivered. It's not like we are deploying everything on the production in that sprint. It's not like that. It's like that we are, it's something like we are committing before the sprint. Okay, these are the things we are planning to do in this sprint. We plan it. Okay, then people in the project, they are working on it every day, and we have something called daily stand-ups. Okay, we have something called daily stand-ups or sprint meetings, stand-up meetings. We have something called stand-up meetings or daily stand-up. So every day, these people, the people in the team, they are talking with each other every day just to be in sync. Okay, so this was a thing which I did yesterday. This is a thing which I'm planning to do it today. Okay, and they discuss what are the things that are blockers. Okay, so this is in this stand-up, this is a short stand-up meeting where everyone gives their status, what is the current position of the task they are handling, and what are their blockers. So everyone is aware of what everyone is doing. Correct. So there's a collaboration. It's not like that people.
That is done by the DevOps, isn't it? So that is it, or
what?
is it done by DevOps or is it done by everybody?
I didn't get it. Is it done by DevOps? You're saying?
Yeah. That
No,
sprint.
this is like, these are the practices. This is agile practice which I'm telling you. Okay, this is agile practice. There's Scrum. You will hear the word Scrum, Agile.
Yeah.
So these are the practices. These are the practices that we do. We do stand-up meetings. We have this concept of sprints. Okay, we have 14 days sprints. Okay, it's these things we are doing because we want to deliver things in iterative way.
Okay.
Sprints are basically the iterations. Okay, we'll not wait for complete 4 months to show something to our customer. Okay, we have a product manager. Okay, and to that product manager or a client, we will tell them, okay, this is the thing we have worked on this sprint and we are delivering in this sprint. Okay, now he has a view that, okay, in this sprint, this part of the work is done and is working fine. This is delivered. This is the logical end to this particular task. He knows that.
Okay. I thought like for DevOps, because we need to bridge the communication gap, right? We need to do something like this.
So DevOps is like, it's on more technical front. Now do not confuse between do not confuse between the, I told you, these you will work on these together. You will not be able to segregate these two things, agile and DevOps. The difference is how these things are bridging the gap. Okay.
Yeah.
The difference is this, where they are bridging the gap. So usually as I said, we usually work on both the things. It's not like we are working on agile or we are working on DevOps. We are working because our aim is to deliver fast and customer satisfaction. That is our aim. So that can be achieved when we bridge both the gaps, right? So with DevOps, there is no blame game. So everyone is responsible for everything.
Okay, not just the DevOps, yeah. So everybody is responsible.
Yes, everyone is responsible for everything. So in the DevOps team, the person who is there'll be a different development team. That is fine. But DevOps team would be doing this.
Still that mindset will be there, right? But what I'm trying to say, in working environment, that mindset will be there, right? People will still say, oh, it's a DevOps team, they have to do it. These things.
Yes.
So these things, do they happen?
Yeah, but the thing is, they will be like more comfortable with the understanding the code, and if the things require change, they can do it. Like proper development team, there will be various development team. Okay, there will be various development team. I agree, that are proper doing building the code, building the website, the code development team will be doing. So now the thing is, people are shifting towards DevOps.
Yeah,
it's not like that. They will shift it in a one day. It's a phase, right? It will take some time to shift towards DevOps. So right now, what is happening in various companies, you would see even the proper developers. Okay, the people who are working on Python, Java, and these things, developing the websites and everything, even they are doing these things, the DevOps part. Okay, they are doing the code, they are doing the testing. After doing the unit
and they're
testing, they
doing
are doing the release, they are doing the building the images of that, they are deploying that containers, and then they are monitoring this, and so they are doing everything.
wow.
So that is like, so that is proper DevOps. So that is like 100% DevOps, you can say. Only one person is doing everything. So it is not feasible everywhere, right? So
I mean, it's not possible, right, for a big environment to one person to handle,
no, I mean
unless
you
it's
have a
a very
team.
small piece of work, isn't it?
So I mean you have a team. It's not like there is a one person in the
Yeah.
team. It's not like that. I
Uh-huh.
mean you have a team and everyone can do everything. It's not like
Oh,
that. I
okay.
have
So
a.
that means
It's not like that. I have a.
okay.
I am employing a person who is only deploying the things.
Right, I
Okay,
understand.
I
Yeah,
am not
yeah.
employing a
Oh,
separate person who is only monitoring. But earlier,
Hmm.
what used to happen in the case of waterfall models and previous approaches, I used to hire a person who is just monitoring my uh, servers, who's monitoring my infrastructure. You must have seen the jobs earlier used to come.
Yeah.
Server administrator, database administrator, these kind of jobs used to be there. But right now you must be seeing these jobs are
Yeah, I mean,
vanishing.
now cloud is like everything. Yeah,
Yeah, yeah, it's
you
taking
need to know
everything.
everything.
Yeah, right. In cloud, you can do everything in cloud. You can develop applications, you can build, you can deploy, you can monitor, you can release, you can have various life cycles. Like you can have a phase of production, pre-prod, then development test. You can have various environments. Everything you can have. Everything you can have on cloud.
Yeah.
Okay, so things are gradually changing, and organization might not be working fully on DevOps, 100% DevOps. It cannot be, but it is possible that they might be doing 100% DevOps. For
Okay.
example, startups, you can say various startups. So there are less people there, right? They cannot afford only one person to write a code, another person to build, another person to test, another person to
Oh.
deploy, another person to operate. So there they have 5 people, and all 5 people do everything.
Mm.
Okay, so that is where the DevOps comes in.
I mean, you also do like this, or you just do?
For me also, so here also I have worked initially as a developer.
Yeah.
When I started my career, I worked as a Java developer. But now here, like since many years, I have not written much code.
Okay.
Like bits and pieces, I know I have to write somewhere for automations and things on for this DevOps part for automation, because in DevOps automation is very important. Okay, without automation there is no DevOps.
Okay.
Okay, so we'll see where the automation comes into picture. So automations, you have to write some code, right? Some Python scripts, basic shell scripts. Okay.
Yeah.
Even when we study Jenkins, we'll see running these pipeline, the Groovy scripts. We'll see how to write it. So these are but simple. It's not like that I have to do a mastery of a programming language to write this. No, it's not required.
Okay.
I can do it without as well.
Yeah.
Okay. So you got the idea of DevOps?
Yeah.
Okay. Then we have various stages. Okay. So these are the stages what we have. So first is version control. Version control is what? You write a code. So first, what we discussed, we saw writing a code, right? So what happens in a team usually? There are multiple people working on the same code, right? Like on the same, there's a code, let's say for my Amazon website, let's say there is a code. There's a proper coding thing there. Okay, now I'm working on some code. I'm working on some part of the code. Let's say uh, I'm working on the payments page. Let's say I'm developing the payments page. Okay, now I have written the code. I have deployed it somewhere. I have written the code somewhere. Now, some other guy who starts working on some other part of the code. Now, let's say a developer XYZ, he's working on orders page. A developer another developer is working on the cart page. So all of these people are working. So there should be a place where the code has to be there, right? There should be a place where the code has to be stored. So that thing is called a repository, that we call as a code repository, where you store the code. And there should be a versioning on it, right? Let's say I store the code somewhere. I can store it on my local laptop as well. I can store it on my hard disk. So what happens? What will happen in that case? Now I am writing the code. I copied the code in my hard disk. Now on the same code, a person B has to work. I'll give him this code. Okay, take this hard disk. I have written this code here. Start editing that code and create a new version of the code, whatever you mean. Okay, now let's say developer C is working on developer C is working on a different part of the code. So what will happen? He'll take the same code and he'll start working on it. But see, they are improving the version of the code, version 1, version 2, version 3. We do not have any versioning enabled right now. I cannot see that what was the change I did in version 1, what is the change that was done in version 2, what was the change done in, what was the change this particular guy did, what was the change which this particular guy did. So this is not possible, right? So the first stage is for version control. We have to version control the code. In version control, what happens is we have a repo where we store the code. Okay, and whenever someone wants to store the code, whenever someone wants to work on that code, he creates a branch. He creates a branch out of that. He works on his particular branch. Okay, and let's say parallelly another person wants to work on the same code. Then another person also takes the branch from the main code. He also starts working on that code on that branch. Okay, now both the people commit that code. Commit the code as in commit their versions. Okay, this is the code, this is working for them, and they are committing the code to the master, to the main branch. They are pushing the code. Now on the master, if I see, I can see what are the changes that this guy did. Okay, what are the what was initially in version 1 and what is right now in the version 2. I can see that on the master. Okay, so this is how I'm versioning my code. Okay, we'll discuss more on it when we tomorrow when we are starting Git. When we study Git, we'll discuss more on the version control. But to get the idea of version control, right? The code has to be managed. You're writing a code, it's not like you have to save it on a laptop and another guy is working, he's saving on his laptop, and third guy is working on the code and he's saving on his laptop. What if the laptop goes down? What if the laptop crashes? Your code is gone, right? So it should be stored somewhere. It should be stored in cloud. It should be stored in a common repository where everyone in the team can access the code, can see the code. And whenever someone wants to change the code, he can take his branch, change his code, and commit his code to the master so that other people also see the updated code, right? You got the idea of version control? Any doubts on version control?
Yes, yeah.
Okay, we'll discuss more on it tomorrow when we start Git. Okay, then there is something called integration. Okay, there is something called continuous. Now things you might be hearing is continuous integration, continuous delivery, continuous deployment. What are these things? You must be hearing all these things.
Yeah.
Okay, so what is continuous integration? Continuous integration is like we studied all the phases of development, right? You have a build phase, you have a coding phase. Okay, then you compile it, you create a jar or executable, then you validate it, then you unit test it. Okay, and then you integrate it with the full code. Okay, so this part is called continuous build or continuous integration. Okay, what is continuous build? Continuous building is you are the code which you have stored in the repo, which is in your main branch, which is in your repo, is built continuously. Like whatever changes you are deploying it, what is building the code? Building the code is creating an artifact, right? Creating executable, like we discussed. Like you will not give the whole the running 2000 line of code to your end user to use it. You will
Hello?
create a
Lost
jar
your
file.
voice.
You will create a tar file. You will create an executable. You
hear
will
me?
create a war file. Yeah.
Hello?
Yes. Did you say something? Hello.
Yeah, I can hear you now. Sorry.
Okay. Can you hear
something
me?
happened. Yeah.
Yeah. So you will create a in code build, what we do, so this is what building is. Building a code means creating an artifact, creating a jar file, creating a tar file, creating a war file. So that is code build. And whenever you change your code, like that is what the version control is, right? What is version control? Version control is maintaining the versions of the code. You might have version 1, next day you might improve the code, it becomes version 2, another day you might improve the code, it becomes version 3. So continuous build is whenever you build a code, whenever you create a code, whenever you commit a code, there is a build happening, and that build is automatically creating a jar file. Okay. Let's say you have version 1. You create a version 1, code build happens. A jar of version 1 got created. You create version 2, a jar of version 2 get created. You create version 3 and commit it, a jar of version 3 is created. So this is what is continuous build. Okay. Then there is continuous integration. Continuous integration is what? When your code is built, your artifact is generated. For example, a jar file, a var file, or tar file, or whatever, all the kinds of executables it gets generated. What happens? It gets, you review it, whether it's working fine or not. You do unit testing, you do integration testing. Okay, so till here it's continuous integration. So continuous integration will include everything. It will include version control, continuous build, till continuous integration. It will include everything. You got it till here?
Yeah.
So we are slowly we are moving one step up. We are moving one by one step ahead. Okay, so this was unit testing that we are doing, integration testing that we are doing. So now what happens? There is something called continuous testing. At the point of continuous testing, what happens? Here, when you build a code, when you commit a code, your jar file gets generated. Okay, your jar file gets, you compile it. You compile your code and your jar file gets generated. Then you do a validation. Then you do a unit testing, review the code and whatever happens, and then do an integration testing a bit. Okay, then you do a continuous testing. Continuous testing till here it means whenever you do something, everything is happening till testing part. Everything is happening again and again. When you do a version 2, same thing will happen. A build of a jar will be created. Okay, a jar will be created, and then it will be a unit testing will be run. So these are all automatic. You don't have to trigger anything here.
Yeah.
Okay, it's not, there's no button that, okay, if you click this button, that you are in this continuous build, and if you click a button, you will be on a continuous integration or continuous testing. There's no button. So continuous testing is, it will use testing as well. Okay.
I'm getting confused. Here they're saying testing as well, and then number 2 is also testing. What is the difference here?
So actually the thing is, this is, you have these stages. Like these stages are in the terms of the task force they are doing. So version control, what is the thing version control is doing? Version control is doing the source code management.
Yeah.
Okay, version control is doing the source code. You got the idea of source code management?
Yeah, that is okay. Then number 2
is doing the build.
building
Building is just building your code and doing the unit testing. Okay. Then continuous testing. Then after you get deploy it somewhere, right? You deploy it, you have some environments, not the production environment. You have the environments such as dev environments. Okay, you have dev environments, right? So you do all those testing and everything. These testing, integration testing, these are done on dev environments and lower environments. Correct. So then it comes the continuous delivery. Continuous delivery is the process where you have deploying the build application to the test servers and performing UAT. So here your UAT teams comes in. The person who is actually the tester, I meant to say the UAT testers, they do the testing here.
Okay.
They're not. It's all automated. Here,
Yeah.
it's all automation. We'll see that how these things are automated. I'm just giving you the idea of the terms, what these terms actually mean.
Yeah.
Okay. Delivery is continuous delivery is till the point before deploying to the production. Okay. Continuous delivery is till the point of deploying to the production. Means before deploying to the production. Okay.
So I mean, in number 2, we are basically having the source code. We are building it and just doing basic testing like unit
testing and integration testing, normal integration testing.
And number 3, we are deploying it, isn't it? So we are going to deploy the build to the servers and
To the
perform
UAT servers,
So,
not production servers.
okay,
To the
UAT product
smaller servers, not non-prod servers, you can say.
Okay.
Okay.
Right.
And if I say,
So
if
who
someone
will do the test? Is it just the customer, or we will be doing the test?
customer
So
will not
number
do the
3.
test, so it depends. You can write. So now what happens is nowadays everything is automated, right? We write test cases, we create a script, and everything is automated. Everything is with Jenkins. We'll see everything is automated.
Yeah.
Okay, you have Selenium tools, and you have various things in testing. So
Yeah.
you write some prepare some test cases, and your code is checked with those test cases if these test cases are working fine or not. So it happens with a click of a button. So what happens if I say my project is based on continuous delivery? What does that mean? It means that whenever my developer is writing a code and committing it, the process starts. Okay, process as in as soon as he commits, nothing else has to be done. There is no job, nothing else to be done. Now whatever I'm going to say next will be automated. Okay, when he clicks a commit, automatically there is a jar file which is built, or an executable file which is built. Okay, with that jar file, there might be some unit test cases which might be written. So that unit test cases get executed. Okay, after the unit test case gets executed, this gets deployed to somewhere like any higher environment, let's say UAT environment, and there also all those testing happens if everything is working fine or not, with integrating all the changes, all the components. So till here, till continuous delivery till here at this point on my pre-prod servers or before the prod servers, everything is working perfectly fine.
Yeah.
So I'm now happy with it. So it will have other stages as well. We'll discuss later what are the other stages. Other stages which we have already seen, like all these stages, monitor and which we saw here. Release, build, deploy, blah, 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 whatever. All these stages will already be there. So here also these things will be there.
Okay.
It
So and
continues
these and these testing will be done by the testing team, or just do we need to test it?
There'll be test cases written.
Yeah. Okay.
Test cases
We
we'll
just
automate it. Yeah, we'll automate it. We'll write some test cases. We'll create some scripts, and whatever is it will be in the flow. It will be in the complete flow. Whenever someone commits, let's say a version 2 is coming now. Okay, our version 2 is deployed and it's running perfectly fine. It's and continuous delivery has happened till it has been deployed on pre-prod this UAT environment as well. So now let's say version 2 came in. My developer develops and commits version 2 of the code. Now again the process starts. When he commits, as soon as he commits, there is a build of that. The code is compiled and a jar file
Yeah.
is built. Okay, code review is happening. In code review, what do? We use Sonar Cube and things like that. That will review your code, like whether you are following all the best practices and
Mhm.
whether your naming your variables is perfect or not.
Mhm.
And there are various things. So it will check, it will do the code review, then it will do the unit testing, whether the code, the version 2 which you have deployed, and the unit test cases that you have created, are these adhering to that test cases or not? Is the code adhering to to those test cases or not? If it is
And
successful,
there's no need for a testing team at this stage for these.
no, there is no need of
Oh.
testing. So that is
Oh.
what DevOps is, right?
Mhm.
So someone has created it. Someone has created
Mhm.
test cases. Now
Mhm.
you are integrating those test cases to these.
Okay, so we are not creating the test cases. Yeah,
No,
we
you are not
use
creating the
the
test cases.
cases. Okay, okay,
You're not
right,
creating those test cases.
right.
Okay. You're integrating everything.
Okay,
So that
okay.
is what. So here you do a review, then do a unit test, and then after unit test, what will happen? The code will be deployed to a higher environment. Let's say UAT environment.
So
Okay.
in number 2, let's say something happens, right? It is not successful.
Hmm.
So how does it go back to? Does it go back to number 1 or
Yes, it
does
will
it?
fail.
Mhm.
It will fail. Let's say
Uh-huh.
if the compile fails, version 2,
Mhm.
it's a code. Code is, let's say if the build, even the build fails.
Yeah.
Okay. So it will
Yeah.
again go to the number 1. It will not go, but
Number 1.
the pipeline will fail. The
And
pipeline
who
will
will
fail.
be the owner at that time? It will be the developer, so it goes to the developer team.
Yes, it will go to the developer because developer is the one who is fixing the code. And
Okay.
here it will be like the person who is the DevOps person. Okay,
Yeah.
the DevOps person, what will he do? He'll check check the errors. What is the error in this code? Like what is the
Okay.
error that he's seeing in the pipeline? He'll see all the pipelines and stuff later.
Yeah.
But you will see all the error. Error might be multiple things. There might be some issue in the code. There might be some issue in the
Syntax, yeah, like
syntax,
that.
and whatever. Many issues can come.
Yeah.
Your code review might also fail. Okay, when I'm
Yeah.
talking about Sonar Cube is a tool that we will use for code quality checks. So it might also fail. So our pipeline will fail. Okay, it can fail at multiple places, right? Even at continuous delivery, there might be some performance test cases or some test cases which might have been written. They can also fail. Okay, there might be errors everywhere. That is what the best thing about DevOps is, right? So for every stage, you can track what is the error in this stage, what is the error in this stage. Okay, so continuous delivery is still the point you have deployed to a UAT environment. Now, what is your ultimate objective? Your ultimate objective is to deploy it in production, right? So,
and this part of the testing where we got the build code, and then we are going to test it in a testing environment. And all these, do we have like test cases for this testing environment, or is this something that we have to?
no,
build?
you don't need to build the test cases. You are not on the application development side, right? Like the person who is actually developing it, he's writing the unit test cases.
Yeah.
Fine. And the person who are the actual testers,
yeah,
who are the actual testers, they have to write the test cases, the proper test cases based on the detailed requirements that they can do using various things like HPQC, and they have those tools for that.
Yeah.
Okay. So that they prepare, that you don't have to prepare.
Okay.
Okay.
I mean, number 3, we are testing how the application behaves in the test server, right? Is that correct?
Yes, how the application is running on the test server.
Yeah.
Okay, so till here it is continuous testing.
Yeah.
Okay, but after that you need to deploy on production as well, right? So,
so in this stage, sorry, in number 3, this is performing UAT, and normally UAT is performed by the customer, isn't it? Is it a customer UAT or?
It depends. It depends.
Yeah.
It can be customer
So
UAT. It can be your in-house UAT. It depends.
Okay. So we can bring in
difference is it
engage
is
with
not
the
production.
Yeah.
It is not production.
Yeah, and we are we able to still bring in customer to do some testing, like trial testing in this stage?
It depends. It depends on it depends on organization and the project.
Yeah.
In some
Okay.
organization, it can happen that a customer, there's a separate team from the customer who is doing this UAT testing.
And
in
there's
some
no restriction as such, isn't it? So they can
no,
always
this
get
is a
involved in the
process.
life cycle. Yeah.
No,
Okay.
this is just a process. This is just a process. So the DevOps is just a process. You can modify it as per your benefit.
Yeah. Okay.
Okay, you can modify it as per your benefit. You might not require a code review tool. Let's say you are not using SonarQube. Just leave it. Let's say I don't need it. I'll not use it. I'll just build the code and just deploy it.
Yeah.
So it depends on your organization and how you want to mold it. How you want to mold the process.
Yeah.
Oh, okay. So if I say continuous delivery, so this means that 1, 2, and 3 together. Okay. 1, 2, and 3 2. It's not like if I say continuous delivery, I'm taking care of this because I need these things as well, right?
Yeah.
For continuous delivery. But if I say that continuous delivery, that means the deployment is on production is everything. Everything is ultimately going to get deployed on production, right? So after delivery, let's say we have a button. Or let's say we have approval from somewhere, from a higher authority, that okay, things are working perfectly fine on UAT environment. Now it is good to go. Now we are good to deploy it on production. So now we deploy it on production. So this will be continuous delivery only, because we have a trigger, we have a manual trigger here that is requiring an approval from a higher authority that okay, things have worked perfectly fine till UAT. Now all the test cases are passed, all the things are running fine. Now I'll say a go, and after the go, please deploy the things on production. Now we'll say a go and you deploy the things on production. So this process will be continuous delivery. Okay, this process will be continuous delivery. Now what is continuous deployment? Continuous deployment is you remove that trigger as well. You remove that button as well. You do not have any higher authority right now with you who will come to tell you that, okay, now it is the right time to deploy the things and I'll give you a go only then after you deploy things and then things like that. Now, if you say my project is based on continuous deployment, so what will happen? When a user commits a code, build gets generated, all the test cases, code review is happening, all the unit test cases are passed, then it's deployed on the UAT, all these things are passed, and then it get deployed on production as well. So that is continuous deployment. Okay, with the single commit of a user, after some time, things are getting deployed in production. So that is continuous deployment. Okay.
Yeah.
And just before that, after the commit, and if it is happening till the UAT side, but there is a high authority or there is a go required or there's a button, you have to click it and then it goes to the production. Then we call it, it's a continuous delivery. Got the difference?
Yeah.
So this is a important interview question. So interview question is a very, it's a favorite interview question for the interviewers. What is the difference between continuous delivery and continuous deployment? Okay, they might ask you this.
Okay.
Okay, many people don't know this. Okay, many people do not know this answer. Because I have been taking many interviews and they know, they have been working on DevOps since a long time, but they don't know what is the actual difference between delivery and deployment. They often get confused because they say that, okay, the things are running on production. That means it is continuous deployment, but it's not like that. You got the difference, right?
Yeah. So what should be the ideal answer? Like if they ask that question, let's say.
So ideal answer would be this. So you can answer that. The difference between continuous delivery and deployment is for a continuous deployment, for a continuous delivery, continuous delivery is till the point we have everything till on the UAT servers, or before the prod servers, we have everything running, and whatever we do, whatever the developer commits, everything is running and perfectly fine on code is built, code is developed, and this code is built, unit tests are run, and everything is get deployed on your UAT servers. But you need a click of a button or approval from a higher authority or a trigger to deploy it on production.
Okay.
So this is called continuous delivery. But if you do not have the need of this trigger or have this approval, then that is continuous deployment.
Okay.
Everything is automated. Everything is
Yeah.
automated, and starting from a user to developer to click on the commit to deploying on production. So that is continuous deployment.
Yeah.
Okay, this you can answer.
Okay.
And continuous monitoring, that happens in everywhere. You have to monitor everywhere. You have to monitor. Monitoring will happen everywhere. When you are building the code, while testing it, even in your production. So monitoring will be there. So that is called continuous monitoring. So these were just the terms. Continuous, you see, continuous build, continuous integration, continuous delivery, continuous testing, continuous deployment, continuous monitoring. So these are terms. You write continuous here because these are happening continuously for every iteration, for everything it will be happening it. Okay.
So it's just like sending an alert. I mean, an alert, like an email or to say that, okay, this has been, I mean, like, a version has been added to the repository, or like, unit test has been completed, something like that, right? Or what is the monitoring actually alert?
Monitoring alerts, it can be alert as well. Monitoring is nothing. Monitoring that we discussed, right? There can be monitoring of the logs. Alerting is also monitoring. So after every build stage, you can notify your stakeholders. Okay, integration is successful, or if it is a failure, then it has failed on the compile time. It has failed on UD testing on this particular use case, this particular test case. So you need to monitor these things, right?
Okay.
So we'll see how this Jenkins pipeline, how does it do everything in it. So we'll see that. Any questions on this? These DevOps stages?
I'm okay. So
Any questions till now? So basically all these are the stages. You will hear most of them, like every day you will hear these stages: content integration, continuous delivery, deployment. But when you are actually working on a DevOps project, you will not hear these terms. These are
yeah, I mean, these are like interview questions, right? Some basics.
these are interview questions, plus you should
Yeah.
know like what is delivery, deployment, you should know. But when
Mm.
you're working on, you will be so much involved in these phases that you will forget about these basic things.
Yeah.
So maybe that's why people are not able to answer these basic questions on delivery and what is continuous delivery and continuous deployment. But you cannot, interviewer ask usually this question. And you cannot say no, that no, I do not know this question, because you are working on DevOps, and if you don't know the difference between continuous delivery and continuous deployment, it's like you don't know what is DevOps. Like what you don't know what are the things you're working on.
Yeah.
Okay, so we'll cover many tools for all of these stages. So tomorrow what we'll do is we'll cover on this part, version control part. Okay, we'll cover on the version control part. We can start it today also. So we have just 5-10 minutes remaining. So I'll give you an overview for tomorrow. Okay, so that you are prepared for like what are we going to discuss tomorrow. Okay, so I today told you what is version control. Version control is, why do we need version control? You know that, right?
Yeah.
So it cannot be like 10 people are working in a team, and I have a code. I'm writing a code on my laptop. I'm saving it there. Other person is writing a code on his laptop, saving it there. Third person is writing a code and saving it there. And no one knows what the other person is doing. And at the end, they are delivering something. It does not happen like that, right? There should be a common repository where you have that code. There should be a common repository where you have that code, and other people can see that code. Okay, this is my repository. This is my code. I can see it. What can be the other situation? Other situation can be, let's say you have a repository, you have a branch. Okay, let's say you have a branch as well. And there are 10, it's not like that there is a single person in the team who is a developer, right? There can be 10 developers in your team.
Yeah.
So, and it's not like that every person is working on, like there can be a situation like every person in the team is working on the same repository, on the same set of code. Okay, let's say your application that you're developing has 10 files, for example. Okay, it has 10 files of code. Okay, let's say a user one has to work on file 1 and file 2. Okay, user 2 has to work on file 6 and file 7. Okay, now what will these both guys do? They will have something to, they will have a repo. They have a repo right now. That problem we solved. Okay, they have a repo, and on that repo is containing the code. That repo is containing the code, and that code is having 10 files. But my developer A wants to work on file 1 and 2. He wants to make those changes, and my developer 3 has to work on, the developer 2 has to work on files 6 and 7. Or let's say he has to generate new files, 11 and 10, 11 and 12, 2 new files he has to generate. So there has to be a way to collaborate, right? There has to be a way that they both can work together. So that is why we need a version control tool. Okay, there are multiple version control tools available in the market. Important ones are, like, popular ones are Git. Okay, we also have things like clear case, and we also have SVN. SVN was like used, I've used SVN previously, but yeah, Git is most popular. Git, you will see, like, most of the places Git is used. Okay, so this will solve all these issues, these challenges, that how are these multiple people going to work on the same set of code. Okay, we'll see what are the concept of the branches, what is the trunk. Okay, we'll see that tomorrow. So this all problem Git will solve. Okay, then we also discussed that when a person builds a code, he has to commit it, right? What is committing means? Committing means saving the file in the remote repo. We'll see what is the concept of remote repo, local repo. This we'll see tomorrow. Okay, let's see Git tomorrow totally. Okay,
All right. Okay.
few more things you will get confused. So for today it's fine.
Yeah. Yeah. It's fine.
DevOps, why do we need DevOps? All the stages, what is CI, CD, continuous delivery, continuous integration, continuous deployment, continuous testing. What is agile? How we work in this agile team? Like, there are sprints, stand-ups. So there are more things on agile. So if you go, like, you can go for a Scrum Master certification or any. So that will give you more idea of, like, what are the practices in agile? What are agile manifestos, and what is the things that agile is focusing on. Then you have sprint retrospectives, and types of meetings. You have sprint planning, where you plan your sprint. You have backlogs. Backlogs is a thing where you have all the items listed. Okay, like, you have many things you have to work on, right? You created iterations, and in iterations also you created many you divide it into various stories, various tasks. Okay, and all these tasks will come in a backlog. Okay, so you have a backlog, and you pull tasks from the backlog into your particular sprint. Let's say my sprint is in sprint planning. I have to plan, okay, these are the first 5 items in the backlog I have been looking at. I'll pull these 5 items from the backlog into my current sprint, and I'll start working on it. And you start working on those tasks. Okay, in the next sprint, you'll pull another 5 items from the backlog and start working on it. So this is backlog. So after a sprint gets over, there is a retrospective. You know what is retrospective, right? Retrospective is like looking backwards, like what went wrong in this sprint, what was a good thing about this sprint, were we able to deliver what we planned in the sprint planning, like what was the productivity, what was our productivity in this sprint. So all these things we monitor when we are working in agile.
Okay.
Okay, so I'm just giving you an overview what is agile. Agile is like a
Yeah.
separate It will be a separate course if I start telling it.
Yeah,
There are
yeah,
so
yeah.
many. You have a Scrum Master, you have a product owner, product developer. I'm just giving you an overview who these guys are.
Yeah.
Okay. There is something called a product owner. Product owner is a person who owns the product. Okay, person who owns the product. He knows about what are the iterations you want to plan. Okay, he knows everything about the product. Okay, what are the things you need to plan that he knows. And there is a person called Scrum Master. Scrum Master is someone who takes care of all the orchestration, like who manages all the people in the team, and he's also doing the work. It's not like that. So that is what the best thing about agile is. So everyone knows everything. That's what I told, right? Everyone knows everything. Even the Scrum Master, he can also go and develop the things. He can also write code. He can also do monitoring. He can also do those things. So Scrum Master is basically doing the he heads the sprint, like the sprint planning, like the plannings. He takes care of the meetings. Okay, all the sending the meeting requests, to orchestrating a meeting. Like in the meeting also you have various things, right? To ask people, to ask people all the activities that they are doing. Okay, so these things Scrum Master has to do, to orchestrate, I mean, to manage everything. That Scrum Master does it. Okay, so Scrum Master is not a fixed role, but yeah, it depends. So for in our company, what in our project, what used to happen, we used to have Scrum Master in a rotational basis. So for every sprint, we used to have a different Scrum Master.
Okay.
Okay, so job is easy. So job is nothing like that. It's not Scrum Master has a separate portfolio, has a separate skills. It's not like that. It's like that. He is the owner of that sprint, something like that. He will take care of everything in that sprint. He will be the point of contact. He will take care of the meetings. He'll start the meetings. Okay, and product owner is at the higher level. Like all these things that we'll do, all the things we will be delivering in the sprint, the product owner will see that. We'll deliver it to the product owner. Product owner is the person who will validate that, okay, these are the things that were delivered in this sprint, and these were the things which were planned. Okay, and these are things which are expected. Okay, and the things are working as expected. So you can go in detail on these things, whatever you, if you want today. Okay, do one thing today. Today we covered a lot of things about agile, about DevOps, about CI/CD, this Scrum practices. Just go and read about all these things.
Okay.
So we'll do like this only. Okay, so whatever I teach in the sessions, so during the day, you will have to go through it.
Okay.
Okay,
Sure.
it's just as a revision. So next day, so today was just a basic. It was just DevOps. What was DevOps and these things. So today was mostly theory. So for the next time, even if we are doing the demos and practical sessions, so we'll have the sessions on weekends, Saturday and Sunday. So you'll have at least 5 days to practice and do the demos and see if the things are working fine or not. Okay. Try to do those things, because for DevOps, there will be more things expected on your side. I'll show you a simple demo, and you will figure it out. You'll practice it. But when working on something complex, you might see some other issues coming in, some other errors and some different type of errors coming in. So in that, you have to debug it yourself. You have to troubleshoot it yourself. Okay, because in the course, we cannot. It is impossible in any world-class course. It is impossible to cover DevOps completely. Like to figure out everything what a DevOps can have, troubleshooting all things, and it's impossible. It's impossible. Even if I take 2 hours for the whole year, like 365 days a year, 2 hours daily, even then it is not possible. Even the next year, the first day, you will see the error which you have not seen during the year. So it's like DevOps is like that. because things are changing. Things are changing.
Okay.
Okay, so today go through all these things: agile, stand-ups, sprints. What is the difference between these CI, CD, and sprint, Scrum? What are the rules? And just go through an overview on that. Okay, because these are the questions that some of the questions that might be asked in your interview, but most of the things you will see in your project. When you are actually working, you will see on the project how these things are actually being worked. There is a board. There is a board that which where you track everything. Where you track all the tasks that have been assigned to you in a sprint, the bugs that have been assigned to you a sprint. Okay, you have Jira task. You must have heard the word Jira.
Yeah.
So you have Jira tasks. You have Azure boards. Okay, no, Azure board is something like same. You have tasks there as well. Okay, and whatever you do. So whenever the sprint starts, so everything you commit. Let's say for a sprint, you have uh, 10 days of effort. 10 days of effort. I'm assuming like a sprint is usually for 14 days. 14 days, assume 4 days are holiday, Saturday, Sunday, a holiday, 4 days a holiday. So a sprint is for 10 days, 10 working days. So you will ideally have the task for 10 days. So 10 days, you will have to commit. Okay, these are the 4 tasks that I have to do in 10 days. Task 1 I have to do in 2 days, task 3 I have to do in 3 days, then task 3 I have to do in 2 days. And similarly, you have to commit on the number of days you have to do that task. Whenever the sprint start, those tasks will be under committed stage because you have committed it right now. Right?
Yeah.
After you start working on it, let's say you start working on task 1 and task 2, you will move task 1 and task 2 from committed to in development stage. Okay, so you have Azure boards or Jira boards. So there you can see what are the tasks. That is pretty a visual thing. You can see that, okay, this is the task I see in my committed stage. This is the task which I'm seeing in my in development stage. Let's see, one of the tasks is blocked. So you will see that task in blocked stage. You can move it to blocked stage. So board is for, so that is what Scrum Master does. He goes through boards of every person. So every person will have a board. That board will tell the person, that board will tell everyone, okay, this is the person. He has this, and this task assigned to him in this sprint, out of which he's working. This particular task is in development. This particular task is in committed, that he has not started. This particular task is in blocked, and this particular task he has already done. Okay, that will be marked to done. Okay. So these are the things that you will see in your project. Okay, got it?
Yeah. Thank you very much.
I was just giving you an overview. This was pretty fast that I told, but this you will see mostly when you're working in a team.
Yeah.
Okay. You can Google it, like how the Azure board looks. Okay, Azure board. Just type Google and check the images, and you will see everything how that looks and everything. Okay.
Yeah.
Okay. So let's meet tomorrow then.
Okay. Thank you.
So any feedback, like do you want me to touch something else, or tell you something in a different way, or the way of teaching? Just let me know anytime. Okay, you can let me know anytime, whatever, because even for me, uh, because understanding level of people are different. So for the first few lectures, it will be we see how we are interacting, like how we are. I'll understand what is the best way of teaching you guys. Like I'll also know what are your expectations, how you want me to go approach. Like you'll understand my approach towards things. I'll know your approach towards things. So let's communicate with each other on that. Okay, you can any day come to me and tell me that, okay, this is that Puneet, this is not right. Tell me, you have to explain it this way. Explain it again, or explain it in a better way, or show me a demo or something like that. You can always come to me and tell me the feedback. Okay.
All right. Sure.
Okay. Okay, then let's meet tomorrow.
Okay. Thank you.
Okay, I'll upload this recording into this repo.
Yeah.
The link I'll share it. Okay.
Okay. Thank you.
Okay. Thank you guys. Have a nice day.
You too. Bye.
Bye. Bye.